Imagine looking into the silent darkness beyond the known planets, where the sun's influence slowly fades into the endless ocean of space. For generations, astronomers believed this distant frontier was peaceful, a frozen shell of icy objects drifting quietly billions of kilometers from Earth. But what if that calm has been disturbed? What if something unexpected has entered the outskirts of our solar system, changing everything we thought we knew? Recent observations have sparked fascinating discussions among scientists about mysterious objects traveling through interstellar space. Advanced space telescopes continue to reveal surprises that challenge long-held assumptions, reminding us that the universe is far more dynamic than anyone imagined. Among these possibilities is the idea of a rogue star, a lonely stellar traveler wandering through the Milky Way without being bound to any solar system. If such a star were ever to approach the distant Oort Cloud, the consequences could unfold over millions of years. The Oort Cloud is believed to be an enormous sphere of icy bodies surrounding our solar system at unimaginable distances. Most of these frozen objects have remained undisturbed since the birth of the Sun over 4 billion years ago. They are cosmic time capsules, preserving clues about the earliest days of planetary formation. Yet this distant region is also incredibly fragile. Even a slight gravitational disturbance from a passing star could send countless icy objects drifting toward the inner solar system. Imagine billions of frozen worlds suddenly having their peaceful orbits altered. Most would continue wandering through deep space, but some could begin incredibly long journeys toward the sun. These travelers would appear as brilliant comets, lighting up Earth's skies centuries or even millions of years after the original disturbance occurred. A single stellar encounter could reshape the appearance of our night sky for generations far into the future. A mysterious visitor at the edge of the solar system introduced the intriguing possibility of a rogue star approaching the distant Oort Cloud and explain why such an event has captured the attention of astronomers. Imagine waking up to news that something enormous is quietly moving through the darkest reaches of our solar system. Far beyond the orbit of Neptune, beyond the Kuiper Belt, and deep into the distant Oort Cloud, scientists are studying unusual gravitational patterns and mysterious objects that continue to challenge our understanding of space. Among the most fascinating possibilities is the existence of a rogue star, a lonely star traveling through the Milky Way without orbiting another star. Unlike our Sun, which anchors an entire planetary system, a rogue star wanders freely through interstellar space, making its path difficult to predict. If such an object were to pass near the outer edge of our solar system, even at an immense distance, its gravity could gently disturb the frozen bodies that have remained undisturbed for billions of years. This idea has sparked excitement because it reminds us that the universe is far from static. Every discovery made by powerful space observatories reveals that our cosmic neighborhood is more active and unpredictable than once believed. While there is no evidence that Earth faces any immediate danger, the possibility of distant stellar encounters encourages scientists to study the outer solar system more closely. Each new observation helps us better understand the invisible forces shaping our place in the galaxy and the incredible mysteries that still await discovery. Explain the Oort Cloud as a vast, icy shell surrounding the solar system, containing ancient comets that preserve clues about the formation of our cosmic neighborhood. The Oort Cloud is one of the most mysterious regions of our solar system because no spacecraft has ever traveled close enough to observe it directly. Scientists believe it forms a vast spherical shell surrounding the sun at distances so great that sunlight becomes incredibly faint. This distant reservoir is thought to contain trillions of icy objects, frozen remnants left over from the formation of the planets more than 4.5 billion years ago. These ancient bodies have remained in deep freeze for billions of years, preserving valuable clues about the early history of our cosmic neighborhood. Unlike the planets that orbit in relatively flat paths around the sun, the objects in the Oort Cloud are believed to surround the solar system in every direction, creating an enormous three-dimensional boundary between our solar system and interstellar space. Although it appears quiet and empty, this distant region is constantly influenced by the gravity of passing stars, the Milky Way itself, and other subtle cosmic forces. Occasionally, one of these icy objects is nudged from its long, stable orbit and begins an incredible journey toward the inner solar system, where it becomes a spectacular long-period comet. By studying these comets, scientists gain rare insights into materials that have remained almost unchanged since the birth of the solar system, offering a remarkable window into our cosmic origins. How a rogue star could affect our solar system. Describe how the gravity of a passing star could disturb the Oort Cloud, sending long-period comets toward the inner solar system over millions of years. If a rogue star were to pass near the outer boundary of our solar system, its greatest influence would come from gravity rather than direct contact. Even at an enormous distance, the star's gravitational pull could gently disturb the delicate balance of the Oort Cloud, where countless icy bodies have remained in stable orbits for billions of years. A small gravitational nudge may not seem significant, but across such vast distances, even minor changes can alter the paths of comets over millions of years. Some of these frozen objects could be pushed into new trajectories, beginning a slow journey toward the inner solar system. Most would never come close to Earth, but some could become spectacular long-period comets, illuminating the night sky with glowing tails visible from our planet. Others might be flung completely out of the solar system, becoming wandering objects in interstellar space. These gradual changes would unfold over immense timescales, not in days or years, but over thousands or even millions of years. Scientists carefully study these possibilities because they help explain how the solar system evolves over time and why new comets occasionally appear from seemingly empty regions of space. Understanding these distant gravitational interactions provides valuable insight into the dynamic nature of our cosmic neighborhood and reminds us that even the farthest reaches of the solar system are connected to the movements of the wider galaxy. Modern space telescopes are revealing new cosmic mysteries. Discuss how today's powerful observatories are helping scientists detect distant objects and uncover previously hidden details about the outer solar system and interstellar space. Humanity has entered a remarkable era of space exploration, where powerful observatories are allowing scientists to study the universe with unprecedented clarity. Modern space telescopes can detect faint light from incredibly distant objects, observe galaxies that formed billions of years ago, and investigate regions of space that were once completely hidden from view. These advanced instruments are also helping researchers better understand the outer reaches of our own solar system, where icy worlds, distant comets, and mysterious interstellar visitors remain difficult to observe. Every new image and every stream of scientific data adds another piece to the puzzle of how our cosmic neighborhood has evolved over billions of years. Occasionally, observations reveal unusual objects or unexpected patterns that encourage scientists to develop new theories and conduct further investigations. This process is a normal part of scientific discovery, where each answer often leads to even more fascinating questions. Rather than proving that everything is already understood, these discoveries demonstrate that the universe still holds countless mysteries waiting to be explored. As technology continues to improve, future observatories and space missions will provide even sharper views of the distant solar system and beyond. With every breakthrough, humanity moves one step closer to understanding the hidden structure of our galaxy, the origins of planetary systems, and the forces that continue shaping the universe around us. The bigger picture: our solar system is part of a dynamic galaxy. Conclude by emphasizing that stars are constantly moving through the Milky Way, making stellar encounters a natural part of the galaxy's evolution and reminding us that the universe is always changing. When we look up at the night sky, it is easy to imagine that the stars remain fixed forever. In reality, every star in the Milky Way is constantly moving, following its own path through the galaxy under the influence of gravity. Our Sun is no exception. It travels around the center of the Milky Way while carrying all of the planets, moons, asteroids, and comets along with it. Over millions of years, the paths of different stars can bring them closer together before they continue on their separate journeys. These distant encounters are a natural part of the galaxy's evolution and have likely occurred many times throughout the history of our solar system. Although such events rarely pose an immediate threat to Earth, they can subtly reshape the outer regions of the solar system by influencing the orbits of distant icy bodies. This reminds us that our solar system is not isolated, but exists within a vast, active galactic environment where gravity continuously shapes the movements of celestial objects. Every new astronomical discovery strengthens our understanding of these cosmic relationships and reveals how interconnected the universe truly is. As scientists continue exploring deeper into space, they uncover evidence that even the most distant regions are part of an ever-changing cosmic story, filled with motion, mystery, and endless opportunities for discovery.